move from the development environment into the build environment. So the build environment, the purpose of the build environment is to create an executable image and to perform functional tests. So creating an executable image means locating and compiling, if necessary, all the elements of the executable image and locating and linking these elements together. Functional tests are done on the whole system. These are automated, and there's a limited amount of data in the database, but you try and make it as real as possible. So go through that in more detail. So the continuous integration server is notified of new commits, or it pulls for them. When a new commit is detected, the server retrieves the new code, and then it retrieves all the relevant code and their dependencies, and then it compiles and links all these pieces, and puts them together. Potential errors during the build process: some code may not compile, dependencies do not exist or can't be found, provided interfaces do not match the required interfaces. These are things that can happen prior to a successful build. Once the build has been successful, then it gets tested, and there are a collection of automated tests, and those are performed using the test harness as we discussed before. And the tests can come from user stories, or they can be regression tests, or they can be rainy day scenarios. There's a trade-off between the comprehensiveness of the tests and the time it takes to run the test. And then the results of the test are reported either through email or a web page. In the development environment, the testing was intended to verify the functionality of a specific section of code, and acceptance was done by the developer, and there were various levels of acceptance. In the continuous integration environment, it's much like testing in the development environment, except that it's done with a complete system rather than a single one. The test data that you use is real, sort of, but it's limited. You need to worry about exposing private data to developers, so there are techniques to obscure data. If you've taken real data from the database, you can obscure some of the personal information. It's limited because you want the test to run fast, and you want to keep the build queue from growing. If the test change the database, then the database has to be refreshed so that each test is independent. And whatever you do, don't affect the production service. That's a no-no for a whole variety of reasons. The environment that you're using includes connections to external services. If these services are read-only, the weather, for example, they can be directly used. If they're read and write, then a test version of the external service should be used. You don't want to affect the external service either. Once its image has been successfully tested in the build, it's promoted to the staging environment. But successful may not mean passing all of the tests. Some failures will stop the process. Other failures may just be noted, but allow the process to continue. Success may be just 95% of the tests are successful. The term orchestration has a broader use than just in build servers, but it means the automated, in the build server, it means the automated arrangement, coordination, and management of the necessary elements. So this includes things like initiating a build on the commit of the code. If the build is successful, then initiate the test. If the test is successful, then automatically move it to a staging server. Generate reports every evening, and so forth. And the orchestration is controlled through scripts. So there are scripts that are used to program continuous integration servers. They say things like where to find the various components, what's the logic to determine the validity of the components, which tests are you going to use, what's the promotion criteria. Essentially, the scripts manage the orchestration. Scripts are programs. Okay, and they should be configuration managed and version controlled, just as application programs should be. A build has multiple user, and a build is single-threaded from the perspective of the user, so it will only do one build of a system at a time. It could be building multiple systems simultaneously. And a build error introduced by one developer affects all the errors because it shuts down the build process. So if you check something in that doesn't compile, then nobody can build that system because that becomes a part of the whole system. And there are social pressures. There's the notion of having a hat that you wear showing that you broke the build and so on, just as a way of encouraging people to make sure that the build is successful. The best practices are that the executable image that you've created during the build stage does not change as it's promoted through to production. That way you're testing the same thing. As I said, breaking the build is to be avoided. And traceability is maintained for all elements. So the build server ought to keep track for each build. Each build has a number or identification, and all of the elements in that are recorded, as well as the tests that are run on that build server and whether they were passed or not. So to summarize, the build service creates an executable image. It tests it for functional correctness. You use limited data, and these things are programmable through scripts.